Hi there. In today's lecture, I want to talk to you guys about splits, mixers, and separators. These are things that's quite important in mass balances, and you need to understand them to solve mass balances. Talking about recycle stream, bypass stream, and purge lines like we started um, earlier this week or last week with this topic, you will frequently come across splits, mixers, and separators. So what are they? When you see something like this in your process flow diagram, the drawings we use for solving mass balances, you know that something is happening to some of the streams. For a split, as indicated here, stream 1 is split into streams 2 and 3. Although the drawing for a mixer looks very similar, we can see from this image that streams 1 and 2 are mixed together and combined to form stream 3. A separator, however, looks exactly the same as a split, but there's a twist. Because a separator is something that sits at that point where the three streams come together or split from. And stream 1 is split into stream 2 and 3 correctly, but something is happening at that node which changes the composition for stream 2 and 3 in such a way that the separator removes some stuff from the stream 1, which it deposits into stream 3, and some stuff from stream 1, which it deposits in stream 2. So there's some sort of split in the ratio of the components in the split as well. And that's basically the difference between a separator and a split. Now let's look at the math for these three things. For a split, like I said, stream 1 is split into stream 2 and 3, which means that the flow rate of stream 2 plus the flow rate of stream 3, the combined stream 2 and 3, must be equal to the flow rate of stream 1. Remember, I've taken 1 and I've split it into 2 and 3. But there's something else about the split that is also useful. And as a matter of fact, it gives us an extra set of information when we look at mass balances with a split. And that is that the composition of every component in stream 1 will be exactly the same as the composition for that same component in stream 2 and 3. The best example I can give for this is think about a cup of coffee. If you have your cup of coffee and you drink the coffee, you're basically splitting some of the liquid out of the stream, putting it in your mouth, swallowing it. So the first gulp of coffee you take will taste like milk. The second one will taste like water. The third one will taste like sugar if you like your coffee sweet like mine. I'm talking rubbish, am I not? Every single time you take a sip of the coffee, it tastes the same. If I split line 1 into line 2 and 3, at that split point, the composition does not change. It doesn't matter whether I put a teaspoon into the coffee or whether I take a sip of coffee, whether I put a big spoon in, small spoon in, spill half of it out. I'm spilling a coffee mixture, which is going to be water, milk, coffee, sugar, the stuff that you put in your coffee. I'm not going to once take milk out and once take sugar out. So how's it possible that if I take the cup of coffee and split it into stream 2 and 3, that the composition will be different at stream 2 and 3? So please, guys, don't ever in your life go have a split and say the composition for component 1 or component I in stream 1 is different to the composition of component I in stream 2. It just cannot be. When we start talking about a mixer, it's basically me making that cup of coffee. Because what we're doing here is we're taking two streams, 1 and 2, we're adding them together, and we are mixing them to form stream 3. Now, if we talk about the mixing, we understand that putting some stuff together means that we're forming something new. And stream 3's composition will be different to the composition of streams 1 and 2. We thus have the combination of stream 1 plus stream 2 giving us stream 3. Adding 1 to 2 equals to 3 in terms of the flow rate. But there's something else we also know from a mixer stream. And that is typically that the compositions of the three streams are different. You are not going to have the same composition in stream 3 as you have in 1 and 2. Theoretically, it's possible to have the same composition in stream 1 and stream 2, and that will give you the same composition for stream 3. But that's not a mixer, because then we have two exactly the same streams and we're not mixing them. So for a mixer, you typically have water coming in, coffee coming in, and I have a coffee mixture, or water with coffee, milk, having a colder coffee mixture. So the composition is not going to be the same. We can also, by looking at the information given, the fact that 1 plus 2 equals to 3, and that the compositions are different, we can also actually write another set of equations that we can use as a test to understand mass balances with mixers. Because we are mixing some component in stream 1 with some component in stream 2, let's call this component I, and component I's got some sort of composition in stream 1 and some sort of composition in stream 2. We know that stream 3's composition for that same component must lie in between the composition for streams 1 and 2. So the composition for stream 3 is either going to be more than 1 or less than 1, and it's going to be vice versa, less than 2 or more than 2. So the composition, if I say, for instance, 100% water coming in 1 and 100% milk coming in 2, then the composition for stream 2 must be less than 100% water and must be less than 100% milk. But it must also be bigger than 0% water and 0% milk, which is the two compositions for stream 1 and 2, and 3 being somewhere in the middle. So we can always use this as a test. If you have a mass balance, you do your mass balance problem, you can go check that the composition for stream 3, that the components in 3 must be less than what is the ultimate value in 1 and 2, or more than the ultimate value in 1 and 2, vice versa, like I've just explained. When we talk about a separator, this is a thing that splits streams 1 into stream 2 and 3, the same way a splitter does. But it tells us about what is happening to components I in 2 and what is happening to that same component in 3, or any other component for that matter. So it tells us that there's some sort of split ratio between those components. So it's a split, but we are told that something is happening to change the composition of the split. A good example of this will be a filter, where the filter will remove the solids from a liquid stream. And in this case, if we had the filter, stream 2, for instance, would contain all the solids, and stream 3, for instance, would contain all the liquids. So we're told that the slurry coming in from stream 1 is split into liquid for stream 3 and to solids for stream 2, giving us the information as to how the things are separated at this split. This is different to a splitter. We still have that the sum of streams 2 and 3 is equal to 1. So the flow rate in 2 plus 3 must be equal to the flow rate in 1. There's nothing more we can say about the composition of streams 1, 2, and 3, because the splitter can split the components in stream 1 into any value between 0 and 100 for streams 2 and 3, and so too for any of the other components. I hope this video on mixers, splitters, and separators helped you a lot. See you again next time.